Good morning, afternoon. This is Mr. Jacobs, and we are now on section 6.6, page 359, and we'll be talking about special product rules for binomials. And so this is the chart of rules for these special products, and there's the sum and difference rule, the square of the binomial rule, and the cube of a binomial rule. So these product rules we'll discover going over these examples, and so we'll start off by just distributing and multiplying using either a generic rectangle distributive property or FOIL method. So let's just multiply and then see if we can find these patterns. Alrighty. So let's start with question number 1 on page 359. And here's the question. This would be the square of a binomial. Okay. So we have a binomial. And what we're going to do is we're going to expand it, x plus 4 squared. So the quantity x plus 4 is being squared. And using the distributive property or FOIL method, you can see that we have x squared. We have 4x. We also have the inner term, the 4x also, 4 times x. And 16, 4 times 4. Now I won't show every step every single time. Since this is the first question, I will. That's my solution. And so the square of a binomial, when the binomial itself is the sum of two terms, when you have this pattern here, it looks like you're taking the first term and squaring it, the last term and squaring it, and then taking the first and last term and multiplying it, multiplying the first and last term, and then doubling that to get 8. So that would be the pattern. It's square the first term, square the last term, and multiply the first and last term together, and then double it. So first and last term would be 4x, double that, you get 8x. And so that's the pattern there. You can do that without having to show every single step. So let's move on. So I'm going to try the shortcut technique and then work it out the long way. So I'm going to take the first term and square it. So 3x squared, what would that be? So I'm going to try the shortcut first. So this would be 3x squared, right? And that's going to give me 9x squared, okay? Now, so that's what I worked with there. Now let's take the last term, which is a negative 8. Okay, and it also works for negative. So negative 8 squared. So this would be my next term, my last term. Negative 8 squared would be positive 64. Okay? And then take the first and last term and multiply it, and then double it. So we're going to take 3x times negative 8, and then double that answer. So that would give us negative 24, so it would give us negative 48. This is going to give me negative 48x. And so the solution to this would be 9x squared minus 48x plus 64. All right? Now let's check that using the FOIL method, okay? So if I was going to use the FOIL method, here's what I would have. I'll just divide this here. This would be like it's the difference between the two terms, okay? Now we go first, I'll do this mentally, last, first outer, inner, and last. fight for space. Okay. And then we combine like terms. And that's the solution. Okay? Moving on. Okay? Same idea. This is called the property here is called the difference of the sum and difference of two binomials. Okay? So there's a special property here, but let's work this out and see what happens. Okay? So we'll try the first. Okay, so you might see that your middle term here, positive 63x minus 63x, cut the 3. They cancel each other. And so your middle terms go away. And so you're left with your first and last term. Okay, and that would be your solution. And so the pattern appears to be that you're squaring the first term, and then you're also squaring the last term. And since you're taking the sum and difference, the value of your last term would be negative 49, not positive 49. Okay? So let's use the shortcut first and the long way. So the shortcut would be the first term is 2x squared, which is going to be 4x squared. And then the last term is 9, right? And you would take the last term and square that. That's 81. And so the answer would be, it's your opposite terms, your difference. And again, if you multiply it the long way, you get that answer, okay? Try another one. Okay, this one's the square of a binomial. So the shortcut method would be take your first term, okay, your first term 8x, square it. Take your last term, 7, square it. Take your first and last term and multiply it, and then double it. So it's 2 times the first and last term. So that's 56 times 2 is 112. Right? I think. I hope I didn't make a mistake. So if that's the middle term, our solution would be if you want to check the work, go ahead and multiply it the long way, which is what I'll do here, just to verify. So let's check my work here. Okay, we're going to take 8x plus 7 and multiply that quantity by the same amount. And so okay, it's working good, guys. Remember, shortcut, use the special properties of binomial products. Long way, hey, just work it out using the full method, distributive property, or generic rectangle. Maybe I'll use the generic rectangle for the next question. Sure, why not? Okay, so I think I'm a little rusty there, so let's try using a generic rectangle. Yeah, it's not bad. So set it up any way you'd like. I can write it as is, 4 plus 3x, and 4 minus 3x. Keep track of those negative and positive signs. I attach them to the number, okay? So what's 4 times 4? To find the area of this piece here would be 16. What's 4 times 3x is 12x. What is 4 times, this negative 3x times 4 is negative 12x. And negative 3x times positive 3x, negative 9x squared. Okay, so you could see here that when you combine these terms, that your negative 9x squared would be the first term, since we're writing it in standard form. Negative 12x and positive 12x, when those are combined, they cancel each other. And then positive 16 would be here, plus 16. So that's the solution. Okay? And again, if you were to use the shortcut method, this would be the sum and difference product rule. And what it says is you take the first term, which is 4, and square it. That would give you 16. You take the last term and square it, which is 3x, and that would give you 9x squared. And then since we're looking at the difference, you would subtract these two amounts. Now, you might say, well, okay, that's going to be 16 minus negative 9x squared, or minus 9x squared. But that's identical to saying negative 9x squared plus 16, right? And you would prefer to write this way in standard form. Okay? Moving on. Number 8. This one says justify the rule for the square of a binomial, then use it to expand the expression given below. So I can do that. So how do you justify a rule? Well, this is something that we've been talking about, justifying things algebraically. Just like a proof in geometry, it's similar to a proof in algebra. So the way we justify is we show our work step by step by step. And so I'm going to do that. So I will show you that this expression on the left side, a plus b squared, is equal to this expression on the right side. Okay? So I'm proving it going in this direction from left to right. That's all I'm showing. I'm not showing that the right expression is equal to the left side. That's factoring. I'm not doing that. I'm just showing that this expression on the left is equal to the right. And there's a difference. You'll learn that more about that later in your later courses in mathematics. So I'm proving from left to right. Okay, so first thing, let's take this left side, okay, and I want to show that it equals that. I want to show that. So I'm going to show that these are equal. So I start what I'm trying to show. So I look at the left side. I'm going to expand it now. So I've still got this left side. I'm going to expand it. I'm going to attempt to make it look like this right side. Okay, makes sense? A plus b, that's the quantity squared. Now let's distribute. Okay, now, my writing's atrocious, I apologize. A squared, got it? Now here, don't be too confused, but when you write the expression AB plus BA, since you're multiplying and it's commutative, your A and your B, the order doesn't matter. So you could rewrite this if you'd like. Rearrange it. No big deal. Same thing. So when you combine it, you've got two ABs, combining like terms, right? Plus B squared. Now, what I've just done is I've taken this left side, And I've shown that it's identical to the right side. So I win. Now let's use what we just learned to expand this expression. So I will erase all this. Hopefully you wrote it. So let's expand this expression here. So we know how this works. We played the game. It's a shortcut. So this says that you take the first term, they call it the A term, this first term, and square it. So we're taking a power and we're squaring it. So that's identical to I'll show all my work. You have to distribute that power. It's a power to a power. So it's, what would be the answer? It would be 4x to the 6. Okay, let's take the last term, the b term, and square that. See that? Okay, let's take the middle term. Well, not the middle term, but the first and last term, multiply it, then double it. So it's 2 times the product of the first and last term. So it's 2 times product of the first and last term. That would be 2x to the third times 6y. So we end up with 12x to the third y, and that's still being doubled, okay? Right? 2 times 6 is 12. X to the third y. You know, their bases are different, so you can't add exponents, right? And when you double that, you end up with 24 x to the third y. And so now we have our terms for our new product, first, middle, and last term. So let's write that out. So here we go. You could easily work this out, expanding it and using the distributive property. Of course, they wanted me to use this rule, though, okay? Just about done, guys. Let's, I guess we can expand this using the shortcut. Why not, okay? So, again, not too difficult using this method. I'll just write it out really quick. Oops. So multiplying it this way is not too difficult. Okay, first, outer, inner, last. The shortcut method says that you take the first term, right? Square it. So 36x squared. The last term, square it. Now you're going to square a negative, so it's going to become a positive. That would be 16y squared. Take the first and the last term, multiply them, and then double it. This is going to be a negative answer, so it's going to be 2 times the first term and the last term. And so I would get negative 24xy, double that, 48xy negative. So my solution is Sum and difference. I like this one because everything, the middle terms cancel out. So positive and negative, your middle terms cancel out. So let's take the first term, 4x, square that. Let's take your last term, square that. Fix that there. Okay. So you have the negative sign there, so it's going to be a positive answer. But technically speaking, you just take the value and not the negative sign with it. So that would be the answer. Let's multiply this through using the distributive property. And also, you might notice that that would be in standard form, if I'm not mistaken, highest power first. I have to double check on that because the variables are different, so we will see. So multiplying this using the distributive property, you'd see that that's 16x squared. This would be positive 12x y to the third. This would be negative 12x y to the third. Cancel each other. And here we get negative 9y to the 6th. Okay? Last question. Same type of situation. I think I'm going to work it out the long way, though. Show every single step. And that's a wrap. That's the first page on 3-page assignment. Thanks for watching, thanks for listening, and remember, study hard and learn a lot. We'll see you later. Bye-bye.